Okay, so today we're going to be talking about lesson 11. This one is more about similar triangles. So last time we talked about angle. So I need two angles to be the same. So this angle and then these ones, if I say they're parallel, then these angles are going to be the same. So I need to know angles in order to tell if I have two similar triangles. So this time we're going to be looking at side lengths, doing some proportional relationships. So those Khan Academies should help you with that. All right, so these are additional notes, and I have them posted on Google Classroom, so you can get these ones. These are going to be the ones that we'll start with, and then we'll move over to your lesson 11 notes if I feel that we need to go over those as well. So this first one, example 1, we have given the information provided are these two similar triangles. So when we're looking at them, okay, we have, this side length is 2, we have a degree of 39 degrees, and this side length is 6. Okay, then over here we have a side length of 1, degree of 39 angle, and then a side length of 3. So when we're looking at this, with what we did last time, would we be able to figure this out, or would we be able to determine it? We'd say no. We only have one angle. If we had a second angle, then we can say, okay, yeah, they are or they aren't. However, we actually can figure this out if we look at it with our side angle side. So this one we can use to determine our shape based on, we need to have an angle that's the same, and then our sides on the exterior right next to it need to be proportional. So we're going to call this triangle, actually I'll make the sign, so triangle 1, and we have triangle 2. So what we need to do is we need to check these. Now when we're working with this, we need to make sure that we do the same one on top of the proportion and the same one on the bottom of the proportion. So like if we want to do triangle 1 divided by triangle 2, then we need to do that every time. And then we need to find the side lengths that correspond. So for example, 2 goes with 1. It's on the left side of the 39-degree angle. So that one would be 2, and 1 would match with it. We should not be matching 2 with 6 or 2 with 3, sorry, and 1 with 6. Those would not be matching corresponding sides. B and C, E and F would be corresponding sides as well. So if we want to, we can write them out. Line A, B, and pairs with line D, E. So that would be a pair that goes together. Now, when we're going to work with this, we need to do triangle 1. So the side length for triangle 1 is 2 divided by 1. So it's going to equal 2 divided by 1. That's going to equal 2 if we reduce it down. Okay, then we look over here on the other side. Okay, we have 6, and the corresponding side of that is 3. So that's line AC corresponds with line DF. Okay, so we'll do the same thing. We'll do triangle 1 divided by triangle 2. So 6 divided by 3, that equals 2. Okay, this is our ratio that's going to determine, or it needs to be a common ratio, but that'll tell us how much we've scaled it up. So I talked about dilation a little bit. Dilation, if you think about it with your eye, your pupil will start really small if, let's say, you're in a bright room. It doesn't need a lot of light in. We turn off the lights, everything's dark because your pupil's so small. Your pupil will then dilate out to where then you can get more light into your eye, and then you'll be able to see better. So there would be a scale factor that we would have dilated by. So, a scale factor of 3, let's say. Here, we would have dilated by a scale factor of 2. We would have increased all these sides to 2 times 2, and that'll give us our side lengths over here. So we can always check with our side lengths to determine it. We need this common ratio. So again, those Khan Academies that you've been practicing on, those will help you to determine if a triangle is similar. So another example is, let's say this side length was 2. We could determine what this side length would be because we know they're similar triangles. So if this side length was 2, then we do 2 times 2, and that would give us 4. 4 would be that side length. So I just threw out a number. That doesn't look like a 2 length. It may be, but I just threw out a number there, so don't let that trip you up. But if if we knew, then we could determine the other side length. All right, so we'll go on to example 2. So example 2, this one has given the information provided. Are they similar? Oh, sorry, this one's up here. Yes, they were similar. Sorry about that. Okay, down here. So now we're looking at them. Are they similar? So what we can do is we know, okay, this angle here is shared. We know that those angles will be the same. It doesn't tell us that these lines are parallel. They sure as heck don't look parallel, but maybe they are. But those lines doesn't say anything about them being parallel. So we can't assume anything about the other angles. We can look at the sides though. So if we look at side AB and then side AB prime, this whole thing is 8. This short part here is 4.9. So we can go ahead and divide that. So 4.9 divided by 8. Okay, now our other side needs to be proportional the same way. So we did the smaller number, we did the, AB, now we'll do AC. So 2.7 divided by 7.1. So then we'll go ahead and do the AC prime. So again, we did the primes and then the original. So we kept that the same way here when we were setting up the proportion. Now all we need to do is go ahead and divide those through, and then we'll see, okay, are they or are they not? So I'm going to pause the video for a second, grab a calculator, and then I'll... So I have the calculator. We'll go ahead and do I got to turn it on. 4.9 divided by 8. That's going to give us 0.6125. And lead broke. All right, equals. So then if these are proportional, we should get the same ratio over here, because we saw up here, we got the same ratio. So we'll look down here, we do 2.7 divided by 7.1. All right, so it's 0.380. Okay, those numbers are different. I'll make that decimal a little bit more obvious. Those numbers are different. They do not equal. So then here we'd say, no, they are not. So they are not similar. So based off of this, we know that the sides aren't proportional. It's not going to be a similar triangle. So that would be what we'd use here. So this one, the sides are proportional. This one, they are not proportional. All right, example 3. So on this one it says, given that these two are similar, so that's what this sign means right here. It means that they are similar. So, and if, I think I told you guys before, but if it was congruent, it would be an equal sign with a squiggly. That means congruent. Okay, so these ones are similar. Could we determine the length of AB prime? So it's telling us already that they are similar. So what does it mean to say that they're similar? We won't talk about that part. But we can determine what that other side is. We just need to find the ratio that we need to multiply to make it bigger. So on this one here, we'll go ahead and set our longer leg divided by our short leg, because that's what we want to figure out over here. So there's a couple ways we can do this. We can set it up kind of like how I told you guys to set up with the percentages. We can do 15 divided by 5 equals X, because we're trying to find the AB. We're trying to find this length here. So that's our side X divided by our smaller. So we have 15, that's our long leg, divided by our short leg, which is 5. It's on the same side. Then we'll do X, this length here, divided by 2, the short length here. So then we would cross multiply. So 15 times 2 is 30, and 5 times X is 5X. Okay, if you want to find the ratio itself, you can just do 15 divided by 5, and that'll give you your ratio, it's 3. But this is another way that we can solve. So now we have 5x equals 30. We want to get rid of this 5, so we'll divide, since these are multiplied together, divide by 5 from each side. 30 divided by 5, 6 equals x. So our side length, our AB prime, equals 6. So that would be our unit, or that would be the length of it. So given that they're similar, we can determine what the length of that is. All right, on to the next one. So if we suppose x and y are parallel to x prime, y prime, so it means this one here and you can draw these on there just to kind of show that they are parallel. Okay, these ones are parallel. If they are parallel, can we use the information provided to determine if these two are similar? Explain. Okay, there's a couple ways we can go about this. We can use the angle that we used last time. So really we have one angle that they share. So O x prime y prime, and then there's O x z x y. Sorry. This one right here, they share. So we already know that one of the angles is going to be the same. Now if we remember, this would be a line cutting across two parallel lines. This angle here is going to be corresponding to this angle down here. So there we go. We have two angles. We could say yes, they are similar. Similarity? I don't know. Similar because corresponding angles are congruent. Okay, so since we know these are parallel lines, we know that this angle is going to be the same because they're literally laying on top of each other on this part, and then these angles here are corresponding. We could verify then that these ones are going to be the same. So these ones would be the same as well. Therefore, all the angles are the same, and that works out. So we can do that. We don't even have to look at the side lengths on this one, which is kind of nice. All right, so example 5, it says, given the information provided, can we determine if OPQ is similar to triangle OP prime Q prime? Explain. Okay, on this one, now we got to look at it, and there's a couple things here. It doesn't tell us that these ones are similar, or sorry, parallel. These lines are not parallel. It doesn't say anything about that. Last time, we could use the angles to determine it because we knew that these were parallel. This time, when we look here, we don't know if they're parallel or not. They look parallel, but we can't be sure because it's not telling us specifically that they are. So then the next step is, okay, well, we know that this angle is going to be the same. Do we have proportional sides? So on that one, we have this side here, but we don't have OP. So we don't have this side right here. Again, we have this side right here, but we don't have the long side. So that's stopping us, and we can't check if they're proportional. So on this one, can we determine? No. We need more information. Now, when you're explaining, I would go ahead and also add, we need either the length of OQ, or we need the length of OP, or we need to know, are these ones going to be parallel to each other? So that's kind of what we're looking at on these ones. These are examples that you can look back on, especially when you get to your homework, to see, kind of make sure that you understand it. Okay. So on this one, I actually want you to go ahead and give it a try. Looking over those 5 examples that we did. So you'll do these exercises 1, and then you'll just stop here at the bottom. So you're going to look at these, try and answer them. A, based on information, are they parallel? Or sorry, are they similar? B, now it tells you that they're parallel. C and D, you'll go and work through those. So give them a shot, and then I'll go over and explain them. Okay, so when we look at this, first we got to go and see what they tell us. So right now we know that triangle A, B, and C, and triangle A, B prime, C prime. So when we look at this, well, they both have this angle A, so that we know is the same, but that's all we do know. So we don't know anything along those lines. So based on information, no, we can't verify proportional sides. Or congruent corresponding angles. So on this one, we don't have enough information to verify what we're looking at. So based on the line, assume the line containing BC is parallel to the line containing B prime C prime. So now we know this would be line B prime C prime. They're parallel to this one out here. Okay, now do we have enough information? Yes, because we know, okay, these are corresponding angles. So that one down there, this one right here. And we know that these are corresponding angles too, because we have two parallel lines and we have a transversal line cutting across. So this again is using what we did last module. Okay, so now, yes, all corresponding angles are congruent. Okay, so now we have enough information. So given that they are similar, determine the length of AC. So AC is this one right here. We need to determine this one right here, A and C prime. So what we can do is again set up a proportion. So we know that this side here, the original side is 8, okay, and then our new side, our C prime B prime, is going to be 2. So 8 divided by 2. We need to then do the same thing here. So AC is your original, so that'll go on the top. And what we're trying to find is the X down here. So again, we'll cross multiply. 6 times 2 is 12, and we're going to set that equal to 8x. Okay, to figure out what x is, we need to divide by 8 from each side. All right, and then we went ahead and divided here by 8. And now we're going to get 4 over 8, that's 3 over 2, it reduces down to, or 1.5 equals x. So we know that side AC prime equals 1.5. Okay, so then we'll do the same here for side AB. Now we need to go ahead and move it back out. So we're going to do the same thing, original 8 divided by 2 equals, now this is what we're trying to find, that is going to be our original. What we have up here is our new dilated form. The original line is always your original numbers, kind of like when we did translation, reflection, rotation. Those original letters are going to be the original line, image, whatever. So when we have this down here, the C prime, B prime, that's what we've moved it to. So that's why I keep saying original over new or prime. So now we do know the prime, so 2.7, and then we'll have to go ahead and cross multiply. So it'll be 2x equals, and so you have to do 8 times 2.7, 8 times 2.7, so that's 21.6. Then we'll have to divide by 2. So we're going to divide each side by 2. X equals 10.8. So that means line AB equals 10.8. Okay, hopefully you ended up getting that. Setting up these proportions is going to be key to working through these and solving them. I do have one more example that I do want you to try. When we're looking at them, we haven't done a lot of these where the triangle's just on its own. So I want you to go ahead and try number 2. Look at it, see if we can tell immediately if it is or isn't, and then try and find those missing sides. If it is similar, it's going to state that it is for the sake of finding them, but why would it be similar if it is? So go ahead and try that. All right, here's the last little bit that we'll do for this lesson. So number 2 in the diagram below, you have these triangles, use the information that's given here. So when we look at these, we have A and A prime, so these two angles match up. You'll notice that they are congruent. So angle A is congruent to angle A prime. Okay, then we look at B, we have angle B is congruent to angle B prime. So we know then our third angle is going to be the same as well. So if we wanted to, we could write angle C is congruent to angle C prime. We can go ahead and assume that because we know if we take 180 minus these two that we will get that last angle, and it'll be the same for both of them. So, based on information given, are they similar? Yes. Each corresponding angle is congruent. So this one we can tell simply based off of our angles. So that's nice because that's what we were doing last time. So given that they're the same, determine the length of A prime, C prime. So we're trying to find this side length up here. So we have to use our original. We need two sides that are going to match up. So we have AB and AB prime. Those are going to be the sides that will match up together. So again, just sticking with the same formula, we'll do original over prime, or new. So we'll do our original 3.6, or 3.2, sorry, divided by 5.12. Okay, now we need to find the one that matches this one. So this is A to C, so we need to find A to C over here. This is going to be the one that we'll use. So you have to be careful, is it original or prime? This one is an original, 6.1 divided by x. And then we'll go ahead and cross multiply. So when we take 6.1 times 5.12, we get 31.232. 31.232 equals, and it would be 3.2x. So to get what just x is, we need to divide by 3.2. If I can draw a 2, that'd be awesome. So 31.323 divided by 3.2. So that's going to be our number. We'll round to the nearest hundredth. So x equals 9.79. So that's going to equal line A prime C prime. And I do want you to label that, saying that these ones are what we're finding. That's what it's equal to. So we know that it's 9.79 units long. If it doesn't give you a unit, then you just say units. Okay, and the last one here, determine the length of BC. So right now we're trying to find this one right here. So we have, again, we'll use AB. So we'll do the original divided by prime. So 3.2 over 5.12 equals. Okay, now on this one, we're trying to find it on the original. So we need to look at our prime. So CB is right here, and we get 8.96. Again, it's a prime value, so we're going to put it on the bottom. Okay, then we'll put x, which we're trying to find, on the top. So again, we'll cross multiply. So we'll have 5.12x equals, and then we have to do 8.96 times 3.2. So we get 28.625. 672. Yeah, a lot of numbers. All right, then we'll divide each side by 5.12. So 28.672 divided by 5.12. And we get 5.6. So x equals 5.6. And x was equal to, we're trying to find BC. The length of BC. So that's how we can use similar triangles to find our missing side length and determine them. So when we're working with them, this is kind of the beginning of being able to use them to solve word problems. So next time we'll be using word problems to try and solve them. And like I said before, this is going to start being used for linear equations so we can determine slope. So that's what we have for similar triangles. Remember, you can come back to these examples. These examples run through at least one example for, I believe, most of what you're going to see on the homework. And then you have these couple examples that you looked at here. So that is all for lesson 11.